Welcome to the Empowering Tomorrow's Automotive Software Podcast, brought to you by ETAS, a single source of cutting-edge software and hardware solutions that make automotive embedded systems safe, smart, secure, and sustainable. Each episode, we'll be joined by ETAS and industry experts to discuss how electrification, automation, and connectivity are impacting the automotive industry. Now, sit back and enjoy the discussion.
Welcome to the show. I'm your host Subhash, and I'll be taking you through today through a podcast as part of our online campaign, Your Ambition is Our Mission. It's a campaign that we started a few months ago and hosted several webinars that we are happy that many of you have also been able to participate on. We are wrapping up this webinar with a podcast. And joining me today is Nigel, who's the head of the RTA solutions at ETAS. Nigel, welcome to the show.
Thanks, Subhash. It's great to be here.
So Nigel, maybe just before we get started, we're seeing a seismic shift in the automotive industry. The OEMs are not just assembling vehicles, but they are beginning to also develop and own software platforms. And these software platforms need to be scalable, safe, and resilient. So when OEMs choose to lead with software, they're not just talking about software and tools, but they're also talking about trust. Yeah. And I believe the ETAS product suite is something that is anchored around trust. So could you just explain what was the motivation for this campaign as it was kicked off a few months ago?
Yeah, absolutely. So I think you said it very well there, Subhash. Obviously, software is becoming more and more critical to the delivery of the automotive products that we want in the future, the features we expect in our vehicles, and more importantly, the updates and enhancements to those features over the lifetime of ownership. But all of that can only be delivered if you have a foundation that enables that software first to be developed efficiently and effectively, and also to be updated over its lifetime. And you mentioned trust is a key part of that. That's because the automotive software environment is a little bit different to maybe several other software environments, that safety and security are very critical aspects of that. Obviously, safety is a very important topic because vehicles have safety consequences. If the software fails, it can lead to an accident. It can lead to the vehicle becoming uncontrollable for the driver and can lead to damage or even physical harm to the driver of the vehicle. Similarly, security is also very important. First, you cannot have safety without security, because if you cannot be absolutely confident that the software is unchanged, then your whole work around the safety argumentation for the software cannot be validated if potentially the security vulnerabilities could lead to the software being changed. And then, of course, security is an important topic in its own right, because vehicles have become a more and more interesting target to be attacked from a security perspective. And therefore, to build this software, this safety and security is an important aspect that needs to live in the foundation, or the platform software, or the operating system that lots of other industries would call it, that sits underneath to enable it. It needs to give you that trust anchor to enable you to deliver safety and security.
That's true. So OEMs have been talking about platform control, but of course, this has gained significant traction in the last couple of years. Why now? Why is this increased traction that we see in the market now?
So I think there's two things. So first is kind of platform software, and platforms have existed in the automotive industry for basically since the introduction of software, but they became really widely standardized with the introduction of AUTOSAR, and especially the AUTOSAR Classic platform a little over 20 years ago now.
Yeah.
And that is providing the platform for all of the control ECUs, all of the hard real-time safety critical ECUs that actually control the physical operation of the vehicle. So run the brakes, run the HVAC, run the wiper control, do the lighting, all of these things that are the hidden little computers in the car. The reason that now we're seeing this seismic change is the expectation from the consumer, and the OEM's desire to meet that expectation is, though, that more functionality is updated over the lifetime of the vehicle, and that these individual software features are tied together to deliver additional value. And that's leading to more powerful centralized architectures, more powerful centralized ECUs, and that's introducing a new kind of platform software into the vehicle. And that's the part that the OEMs are really looking to take a strong hand on, because that's the part that needs to be updated over the lifetime of the vehicle. That's the part where very customer-facing features can be delivered. And consequently, because that can enable the software-defined vehicle, which is a very popular buzz phrase in the automotive industry at the moment, because that's key to enabling the software-defined vehicle or software-defined functionality of a vehicle. That's why the OEMs are looking to take control here, because this is how they will differentiate themselves to the consumer. Less and less is it around topics of the powertrain and interior fit and finish. These all become more and more on a similar level. And therefore, this differentiation is moving more and more to the software, with the centralized architectures being something that the OEMs are wanting to take control. Doesn't mean it's replacing these deeply embedded control nodes. I mean, you still need to control the brakes, you still need to control the window wipers, but you need to tie it together with these new software platforms that the OEMs want to take a leading role in.
That's true. So what you're saying is that I think this is the software that's sort of under the hood, right? It's not the features, the typical ADAS features or so on that end consumers and end drivers would experience, but this is really software that's going under the hood, right? So
Exactly, and that's where obviously our focus has been the last 20 plus years, and where we have more than 4 billion ECUs produced over those 20 years, powered by our platforms to enable those under the hood, deeply embedded ECUs that probably the average consumer doesn't even know there's a computer there, let alone software running on that computer controlling it, and yet it's a critical part of delivering this functionality. But obviously, as I mentioned at the beginning, safety and security is a key topic there, but also critical with those kind of very high production volumes, and also the need to control costs. This software has to be small, fast, and efficient as well, because it needs to run on very small embedded devices. I mean, if you're doing something that's just controlling the window wipers, you don't want to use a very expensive processor for this. So scalability and efficiency and performance is also critical for these under the hood ECUs especially.
yeah. So Nigel, I mean, we know you are very often at customers, especially traveling around Asia, Middle East, and across the world, in fact. So what is the biggest ambition that customers are expressing today when they're talking about platform control?
I think what you see is different strategies in different customers at the moment, but the primary focus is still showing some consistency, which is at the moment the car for the last several decades since the introduction of software and then in-vehicle networking with CAN networking in the late 90s has basically been built as a distributed system with everything roughly on the same level in the architecture. And it's all in the control plane, right? It's all these deeply embedded or under the hood ECUs that you mentioned, Subhash, that are doing the real-time control. What has become more recently a huge challenge for the OEMs is the challenge of integrating. As they've added more and more features, the number of ECUs has increased enormously. And then getting the ECUs to work together and integrate them into the vehicle is very complicated nowadays. I was at a customer just a few months back, and they were explaining in their latest vehicle platform, there's 8 ECUs that are either directly or indirectly involved in a decision, should the vehicle be going faster or slower right now. You've got the ECU that's running the adaptive cruise control. You've got the ABS ESP ECU, and you've got the ADAS ECU that's doing pedestrian detection and emergency braking. All these ECUs are somehow trying to decide should the car go faster or slower right now, and that's become a very huge integration challenge for the OEMs. Therefore, despite these different strategies that I see at different customers, one big thread is this idea of trying to centralize some of the vehicle level functionality and add to what is already there in the control plane a kind of decision-making layer. And that's what's leading to these centralized architectures and the introduction of new platforms as well, is to centralize with a kind of decision and making layer that is then just using the control layer for actuation and sensing.
So yeah, I think we see then that OEMs basically want to sort of control and own this platform stack, but of course they can there are various options whether to develop this themselves or preferably then partner. And how does ETAS sort of enable this ability or this ambition of OEMs to actually own this and take control of this platform eventually?
Yeah, so you mentioned that we've been kind of promoting around the tagline of "Your ambition is our mission," and this is more than just a slogan for us at ETAS. It's kind of a commitment, a purpose statement of ETAS. That being number two here in the market, we're wanting to be very supportive and flexible and offer exactly what the customer needs and not try to dictate too much. So I mentioned that customers all have different approaches to solving this problem. So it can be that we can provide individual components into a platform that the OEM wants to control. So maybe some of the non-differentiating components or the components where the OEM doesn't see strategic value in building them themselves, we can provide these, and then that allows that to be done more efficiently, more cost effectively, because we can share that development cost then across several customers. So that's at one end of the spectrum where we're just providing puzzle pieces, if you like, into an OEM platform. At the other end of the spectrum, we have customers who take the whole platform from us, and we're their partner in the development. Then it ends up a very close, very iterative relationship, because we're continuously developing the new requirements and new features then together to keep that platform advancing to fulfill the functional ambitions of the OEM in that case, because we're responsible for delivering not just puzzle pieces, but a complete functional platform with all of the requirements that they need to meet their objectives. And it's maybe important to realize amongst all of this, the platform is just an enabler. The platform, no one goes into a car showroom and says, take this car, look at that beautiful CAN stack that's in there, look at the platform software, how great that is. The end customer cares about the features, and that's where the OEM wants to focus. And therefore, our focus is to be the enabler, the safe, trusted, secure foundation on which the things that the customers, the drivers of the car in the end, finally care about, and to share that development burden then across many customers. Because despite the size of the automotive industry, honestly, it's not scalable. If every OEM tries to build a complete platform from the scratch on which to build their own software functions, it simply doesn't scale. It's not cost effective, and it will not lead to economic solutions in the long run.
Yeah. So staying with customers, I mean, we know that ETAS is, of course, one important customer segment are the OEMs, but we also have a big segment, which is the tiers, right? So how would you say, are there engineering trade-offs to be made when servicing these two segments of customers? And how does the ETAS's product suite address this?
So I think you see here a bit of a difference in approach in a general term. So let me give the generic picture first. So what we see is mainly for the embedded control ECUs, more often than not, the generic case is that the tiers are in control. So building a lighting control system along with the lighting system itself, building a braking system along with the braking hardware itself. These are typically driven by the tier ones in the industry, who then deliver these systems to the OEMs. The OEMs generically are very focused on the centralized architectures, the decision making, these central ECUs, where these features of the embedded ECUs can be tied together and brought to a higher level in a way that delivers features for the driver of the vehicle that can be differentiating and make then the OEM's products more attractive. So that's the general case, and you see that between, for example, in the deeply embedded domain, you've got standards like AUTOSAR Classic, which is widely used. The vast majority of the industry is using AUTOSAR Classic in this environment, and in the AUTOSAR Classic space, round about 2/3 of our business is directly with tier ones there. So you see the tier ones really taking a lot of control. But it's 2/3, it's not all. There's still business there with OEMs, but that's very often in the case where the OEMs acting maybe like a tier one for themselves. So the role in which they're working with those deeply embedded systems is probably much more similar to a tier one role. It just happens to be an organizationally internal tier one. On the other side, you've got things like AUTOSAR Adaptive and newer initiatives focused on open source and code-first initiatives like S-Core within the Eclipse SDV project umbrella. These are very much focused on the centralized architectures for the central ECUs, and the vast majority of that business, probably today 80%, even more than the two-thirds we see in the Classic. That's with OEMs and not with the tier ones. So the OEMs are driving and deciding in those kind of areas. So the tier ones are critically important. They're driving to the vast extent these deeply embedded ECUs, and the OEMs are primarily focused on these central ECUs with the newer platform software running on big ECUs that's typically on larger microprocessors with a lot more memory, a lot more compute power than the much smaller embedded ECUs for which there might be 20, 40, 80 in the car controlling the various hydromechanical electrical systems.
But maybe when you say that, so if the OEMs are taking greater control of the HPCs or the high performance computers, as you mentioned, what role do you see for companies like ETAS, in this space?
So I think there, as I mentioned, we have customers across the spectrum there. We see a much wider spectrum there. So in the AUTOSAR Classic space with our RTA car product, as I said, it's already in 4 billion ECUs over the last 20 years. And this is primarily sold as a platform solution. It's a highly scalable, highly configurable solution from the very smallest ECUs to the very largest of these control ECUs. And almost all customers take that as a complete solution, as a complete platform solution. We have one or two that just take the operating system or just take the security components or just take the AUTOSAR runtime environment, but the vast majority are taking the whole solution. In the newer and still much less mature microprocessor platforms for these centralized ECUs for the vehicle computers or domain controllers, we have this much broader spectrum from providing just some puzzle pieces of the platform that the OEM doesn't want to build in-house, but they're building the rest of the platform themselves, to providing a complete solution, a complete microprocessor platform software, then integrated with a commercial POSIX operating system, and providing that as a complete solution to the customer. So in this centralized vehicle computer platform, we see a much bigger variety of the solution space in how we support the customers, from these, just puzzle pieces to complete solution. In the deeply embedded AUTOSAR Classic space, it's almost always a complete solution.
Yeah. So maybe let's just come back to, I think the trust anchor, which is of course rooted in safety and security, as we spoke about earlier. And do you see, these requirements also evolving for HPCs, and what new challenges, are foreseen here?
Yeah, for sure. So I already mentioned that when we look at these vehicle computers or high performance computers, the HPCs, as you mentioned, these are much bigger systems. Not what you would traditionally call deeply embedded hard real-time control systems, although they're still safety critical, they're still real-time, but they're running with POSIX operating systems, they're running with external memory, and the safety and security approaches there have to be different to the ones that can be taken in the deeply embedded environment where our RTA car solution runs. So the security vulnerabilities are much broader, much more challenging in these high performance computer areas. The attack surface of a POSIX system in a microprocessor with all of its interfaces, and these ECUs are very often the ones where connectivity into the car is also coming.
That's true.
This is meaning that there are many new challenges there. Similarly, the approach to safety that has been taken in the deeply embedded world is a very traditional classical one of you know a lot about the software statically at design time. You can follow safety standards that define a lot of things a priori with following standards like ISO 26262. That's much more challenging in the environment where the software is being updated continually over its lifetime and where the software is connected. So new approaches to both security are important and safety in that domain. You can't just carry them over because they don't scale to the complexity that we see in the HPC environment.
And I understand that that security, especially with software updates over the air, the security is not just a SOP or a start of production property, but rather it lives on, right, beyond the first SOP as well.
Yeah, absolutely. I mean, this is important for so many reasons, and I think the automotive industry has been learning that to, with some negative examples and negative publicity. So, getting the security right here is critical. I mean, if you get it wrong, you can open up a vulnerability into the vehicle that's very hard then for the rest of the vehicle to manage, and it can lead to your vehicle becoming easier to steal. For example, we've seen examples of that where you can buy devices on the dark web where you can simply remove, for example, a headlight or a wing mirror for a car, connect to the CAN bus, and then unlock the car, start the engine, and drive it away without the key. These kind of things all need to be addressed by a proper architectural security approach. And security, as the classic saying goes, is only as strong as the weakest link there. So security is a very critical topic over the lifetime of the vehicle, and it affects the OEM significantly because that can damage the reputation of the vehicle. But as you also mentioned, with software updates, over-the-air updates over the lifetime, this also becomes important for the economics for the OEM, because security is the foundation then of their business models to make money from this software, to be able to charge for new features, to be able to charge for updates. You can only do that if you know that it cannot be worked around due to security vulnerabilities and be obtained for free. So it's also important to protect the future business models that the OEMs have in mind to catch revenue for software updates, for new features over the lifetime of the vehicle. If they're not done securely, you can guarantee there will be a black market that forms to get those software updates for free or with no money flowing to the OEM, which is then undermining their whole business model for this software-defined vehicle.
Yeah. So let's maybe move on to look at the architecture and also the product architecture. So we know well that OEMs scale from prototypes towards production software, and of course across multiple domains. You mentioned about how the RTA car product also supports these multiple domains deeply embedded, from brakes, engine control, up to wiper control, and so on. Is this then also something which is a single scalable family, or are there different variants that we offer?
So we took already more than 20 years ago a very conscious decision here with how we build the solution to enable it to be scalable from the smallest to the largest ECUs. I mean, you mentioned some great examples there, Subhash. The price and value for an engine control ECU or for one of the more powerful deeply embedded ECUs compared to a small wiper control or a LIN node that's just managing some switches on behalf of the vehicle, for example. The cost of those ECUs can be 1, 2, sometimes even up to 3 orders of magnitude apart in value and cost that they need to hit in production. That means you need to have a scalable software solution that fits from the very smallest devices that maybe only have a few kilobytes of memory, maybe a single-digit kilobytes of RAM, or even less in some cases, up to devices that maybe have megabytes of flash and tens or hundreds of kilobytes of RAM. And the decision we took now 20 years ago is to have a product that is entirely code generated. The reason that's important is it means you only pay the cost in production for our platform software in terms of resource usage, CPU usage, RAM and ROM. You only pay the cost of that for what you actually need and use for your specific configuration. That means we have a highly scalable solution from one code base, one product line that runs on the smallest, dumbest, to use a slightly negative word, ECUs, up to the much more powerful, much more economically valuable ECUs. But the good news there is then you're not having to change solution. It's not different profiles, it's not different pre-configurations, it's not different reference integration packages for these. Everything is generated based on your requirements and your design. And that's what helped a lot with the AUTOSAR standard coming along with the AUTOSAR XML to standardize then how you capture those design properties. And then we generate a highly optimized, highly tuned implementation that basically has the lowest possible overhead for what you need. And you don't pay any cost in terms of runtime performance for anything you don't need. And that's the hidden cost of software in the automotive industry. If you're using a few extra CPU cycles or an extra couple of 100 bytes of RAM or an extra kilobyte of ROM because of inefficiencies in the code, that could cause you to have to move up one variant of the chip, which might add another 10, 15 cents, 50 cents to the price of the microcontroller. And 50 cents times a production volume of 20 million is starting to be very meaningful money. And that's where with RTA-Car we have this highly scalable solution that can actually save you money because it can take hardware cost out
Yeah,
for you.
absolutely.
So
And saves you waste as well, right? I mean, that's
absolutely. I mean, I made the joke comment before, no one goes into the showroom to buy the car based on the CAN stack, but also no one pays for the microcontroller to run the platform software. They pay
yeah.
for it because it runs the ADAS feature or runs the brakes effectively. So the platform needs to be as small and efficient as possible to get out the way and allow the functionality to run. Because in the end, the platform's just there to enable features.
So, and I can imagine that, perhaps this has been one of the most interesting attractions for customers. So is there an example that you could share where, we've been able to enable an OEM to regain control from perhaps legacy vendors or even fragmented tool chains?
Yeah, I mean, maybe, of course, everyone knows that ETAS is part of the Bosch group, and you can imagine Bosch is doing thousands of projects a year as the biggest tier one in the world across all of the OEMs, and they're from the very smallest to the very largest systems, and doing that from the same platform software enables them to have a consistent solution and a consistent set of tool chains and integration of our platform into their wider development environment, into their build pipelines. It enables them then to run, for example, in the Bosch braking area or the Bosch powertrain area, to run thousands of projects, many hundreds every year, off the same platform, just through configuration and change. We also have examples with OEMs who have completely standardized on our solution, and then they're using it on some of the very biggest ECUs, some of the very modern multi-core microcontrollers running RTA-Car, some of the big powerful NXP devices with 10, 18 cores, down to running on devices that have maybe 2 kilobytes of RAM and 16 kilobytes of flash. So that's the kind of scalable solution that we've got, from devices with maybe 16 megabytes or more of flash down to devices with 2 kilobytes of flash.
Okay, that's really interesting. Yeah. So Nigel, I think as you probably have also followed it up. Your ambition is our mission. This has resonated significantly online. Both the technical and the non-technical webinars have resonated significantly across the industry. But what does it mean actually internally at ETAS?
Yeah, for us, and it's a promise and a commitment from us that our job is not done until our customer's project is in production. And with this, what we promise to do is to be a partner in making sure that not only our product to provide this platform software gives that safe, trusted, secure foundation on which our customers' functionality can be dependably built, but that the customer can trust that we'll be there from the beginning to the end of the project to get it into production. So adding features when they're required to the platform software, addressing any issues that might come up during the development project. And there's a couple of areas also where we pride ourselves on being different. I mean, first, we distribute our competency and know-how, our experts, really around the world. So we have a very significant portion of our team sitting in our regional organizations at ETAS. What would traditionally at other companies be mainly only business development and sales organizations, at ETAS we have very large RTA solutions, we call them hubs, that are full of technical experts that can be there close with the customer, on site when necessary, answering in the right language, in the right time zone.
And they're also empowered, right? That's important.
Yeah, absolutely empowered, and they have direct access to go back to the global product team to get additional support when they need it. But it means we put our support as close as possible to the customer, and that differentiates, because what we're seeing is project life cycles are getting shorter and shorter. Projects are having to be delivered in less and less time. I mean, especially in China, the speed at which projects have to run to hit their tight life cycles, this wouldn't work if you had to ask every question from China back to Germany, for example, to get an answer. You would lose a day every time there was an interaction. and these things need to be fixed in minutes or hours, not days or weeks. So this distribution of our technical expertise is one key thing. The second thing is our promise is also to be flexible and find a way that works for the customer, and that applies to everything: the support model, our offering, whether we offer puzzle pieces or complete solution, all the way through to the financial business model. We're willing to discuss and find a way that's a win-win, to be flexible on how to charge for access to our platform project and to make it fit with what works. So whether you want a solution that's a buyout or a royalty or something that scales to a complete company license, everything is flexible here. And that's what we really mean by your ambition is our mission. We want to be partners to help you get your product on the road and into production and into your customers' hands, because until the car is actually being driven by an end customer, the job's not done. And that's what we make our mission, to help our customers get their product into their customers' hands and not to stop supporting until we get there.
That's great, Nigel. So maybe on some closing thoughts. So what advice would you have perhaps for OEMs or customers who are just beginning their platform ownership journey?
So I think it's maybe two different advices for these two different kind of fields of platform software that we've been discussing. So in the AUTOSAR Classic area, where we have our product RTA Car, I think there that the main advice I would give is give us a chance. We know we're number 2 in the market, and because of that, we'll fight harder, we'll work harder. And at the moment, times are tough in the automotive industry, right? The economic situation for all of the OEMs is a huge challenge that filters down the whole food chain. There needs to be vibrant competition here. There needs to be vibrant cost efficiency, and we're here to provide that and to support that. So consider us, introduce competition into your sourcing of the basic software platforms, and we commit that we will live up to this tagline of your ambition will become our mission, and we'll deliver it. On the centralized compute, the high performance computers or the vehicle computers, it's a little bit different here. This is very new. These are all still projects that are heading towards first SOPs and first integrations. It's a much less mature area. One of the things here that I would offer as advice is I think this is an area that needs some deep thinking as to what's strategically important that you do yourself and what can be done through partnerships or sourcing, because a lot of this is not truly differentiating. On the surface, it can seem very attractive to take control, and to take control, you should do it all yourself. But you can take control without necessarily building everything in-house. As I said, I see really a risk at the moment, and we've seen many big OEM initiatives very publicly struggle, have difficulties, or even fail in developing new platforms. And I think that's because doing it alone, it doesn't scale. No OEM is big enough to really do this on their own, and therefore I think the advice I would give is this is worth really careful strategic consideration. What's differentiating? What truly do you need to control by doing, and what can you control by sourcing or partnering or working in standardization ecosystems like SDV Eclipse and S-Core or AUTOSAR Adaptive, so that we can come together and find an efficient solution like we did with AUTOSAR Classic. I mean, AUTOSAR Classic may attract some criticism. I know it's quite popular on social media to complain about AUTOSAR Classic, but it's powered tens of billions of ECUs over the last 20 years. I think ultimately it's a pretty big success story compared to what existed before and would have never scaled, which is OEM specific solutions that are developed exclusively by each OEM. So I don't think we would have reached the software level that we have. So I think that's an important aspect for these central architectures, is to look at what you need to build and what you can work with others on, either through standardization or sourcing.
Yeah, that's a great summary, Nigel. So there you have it, dear listeners. So we've talked about how ETAS's AUTOSAR Solutions empowers platform and also taking over control of software platforms at customers. We've talked about, I think, safety and security as a very important trust anchor, but also the foundation for these platforms. And moving forward, two I think main messages that I took away from what you summarized, Nigel. One is give us a chance. I think we fight hard, and I think we've proven this several times. And on the HPC's areas, I think the jury is still out whether this has to be a completely mixed solution or if it is really something which can also be done with partners, right?
Absolutely. I think that's a perfect summary, Subhash. Yeah.
Good. So with that, thank you, Nigel, for joining in, and dear listeners. So please understand. So ETAS is not just building tools and then embedded software. Through this campaign, we've also tried to highlight that when the OEMs have an ambition to actually have platform ownership, our mission is to actually make that platform rock solid. Yeah. So I'd invite you to also have a look at our webinars online or just visit our website at www.etas.com. So you will find all the information that you need over there. And thank you for listening in and tuning in, and have a nice rest of the day.
Thank you for joining this episode of the Empowering Tomorrow's Automotive Software podcast. Please leave a comment or review with your feedback or what you'd like to hear in future episodes. To learn more about automotive embedded systems and ETAS's capabilities, visit our website at ETAS. That's ETAS.com.